Hello and welcome to this video. This is the first lesson in our new unit, Unit 8. We're going to be talking about data and regression. In this lesson, we're focusing on graphing data. Here's all we're going to cover in this unit. It's a short unit, only 3 lessons. We're going to start by graphing data, then we're going to model data using functions, and then we're going to make predictions using those functions. Our agenda for this lesson, we will cover why we study data, some equations for modeling data, specifically 3 that we're going to focus on, and then we're going to talk about least squares regression. So why do we study data? Well, we study data to find patterns and make predictions or conclusions from those patterns. For example, a company could use sales data to determine whether a new method of advertisement was successful. Or in a more math-related example, mathematicians have been able to model the placement of prime numbers by studying patterns in data. So that's why we study data. So we're going to study 3 types of patterns in data: linear, quadratic, and exponential. If you look at these graphs on the right, you'll notice this first one is a linear relationship in the data. The second one is an exponential relationship, exponentially decreasing. And this last one is a quadratic relationship. And we're going to talk more about how do you know which one to use. So how do we go about modeling data? Well, we use a technique known as least squares regression. How does it work? Well, when modeling data, we want to draw the function that will pass through the points and be as close as possible to the center of the data. You can think of this as minimizing the distance between the line of best fit, which is the line that passes through the center of the data, and the data points themselves. And we call this distance a residual. So for example, here's the data point, and the distance from this to the line of best fit is known as a residual. We can actually create a square based on that residual, and the least squares regression technique minimizes those squares, which we know gives us the best line of best fit. So once we have our line of best fit, we can do some calculations and determine how well our data was modeled. We represent this using a correlation coefficient r squared. Now r squared is always between 0 and 1, and the closer we get to 1, the better the function models the data. So if you look to the right at these 3 examples, each of these is modeling the same data set, but you'll notice that the residuals or the correlation coefficient is different. So which one was the best? Well, this one is the closest to 1, which means it was the best at modeling the data. So this is actually quadratic. So although each of the 3 functions, linear, exponential, and quadratic, did a good job modeling the data, the quadratic was the best. So that's all we're going to talk about in this lesson. In the next lesson, we're going to actually learn how to calculate that line of best fit. For your independent work, you need to answer the questions on the Google form that is listed in the assignment on Google Classroom. Please be sure to send me an email or join me during my office hours on Zoom with any questions. Best of luck.